Okay, so this is an orbit problem, right? Since we have the velocity here, right, we're going to use this orbital equation. We're going to set the force of gravity, which is g mm over r squared, equal to the centripetal force that has the velocity. So mv squared over r, right? And that mass, this is the satellite mass, right? Or is it two t's? See, I just never know. Satellite. Is that the way it is? I don't even know. I honestly got it. Two t's, two l's. Okay, anyway, that mass cancels, okay? And this is good because we don't know the mass of the satellite, right? And then we are solving for the mass. So I'm going to cross multiply. So g mr equals v squared r squared. So this times this is this times this, right? And then I'm going to divide by GR. So m is v squared r squared over GR. And that's going to cancel one of those, and we end up with v squared r over g. So now let's plug those numbers in, right? 3410 squared times 1.45 E7, right? Divided by 6.67 E minus 11. Somehow this has got to have the units of kilograms too, which is fascinating to me. How does it have the units of kilograms? We'll figure this out. But let's do this first, right? So V squared R, so let's go 3410 squared times 1.45 E7 divided by 6.67 E negative 11. And that's 2.527 times 10 to the 24th kilograms, right? Now the question is, that's the exciting part, right? So set up the equation, cross multiply, divide. Sometimes you have to take a square root, right? Plug the numbers in, and then you should get the right answer. Be sure to show this when you're doing your assessment. Show your steps, because if you show this, that's worth points. Okay. Right now I'm just going to look at the units here, right? So we've got meters per second squared in the numerator times meters divided by Newton meters squared per kilogram squared. That's interesting, right? So that is the same as kilograms times meters to the third over seconds squared, right? Kilograms squared over Newton meters squared. That's okay. This is just crazy. Okay, because I just took the reciprocal of that and multiplied by that, right? Okay, let's see. Meters. We're going to get just 1 meter, right? This goes away. So we have meters. Okay, let's see. Kilograms squared. Okay, a Newton is a kilogram. So we've got kilograms squared meters per second squared divided by, and then the denominator here is going to be kilogram meters squared per second squared. Uh-oh, we're in trouble. Because it should end up with kilograms. I'm getting rid of the per seconds. I'm getting rid of a kilogram. I still have an extra meter though. Let's see. Newton meters squared per kilogram squared. Okay. And then that's times meters. Oh, this is really bugging me. Okay, V squared R over G somehow has the units of kilograms. Okay. Okay, so that's going to be meters per second, the quantity squared, times meters, divided by Newton meters squared per kilogram squared, right? Newton meters squared per kilogram squared. Yes. Okay. So that's going to be, let's put everything numerator, denominator, right? Meters to the third, seconds squared, right? And then just multiply by this thing. Is that right? And then a Newton is a kilogram meter per second squared. Oh, there it is. Okay, that's what I messed up last time. Okay, so that's going to be, if I pull this guy out and pull him out in front, right? Divide by that is seconds squared. Okay. Okay, so now we're in good shape. Meters squared cancels meters squared. Seconds squared cancels seconds squared. Kilograms, kilograms. All right, you knew it had to be right.